A company manufactures and sells X radios per week. If the weekly cost and revenue equations are, the cost equation is C of X equals 5,000 plus 2X, and the revenue equation is R of X equals 10X minus X squared over 1,000, for X is between 0 and 8,000. We want to find the approximate changes in cost, revenue, and profit if production is increased from 2000 to 2010. So this problem is going to be solved using marginal cost, revenue, and profit, and then differentials. So we'll write down over here at least one of our differentials equation. So let's say d profit is supposed to be the derivative, the marginal profit, times dx. Just so we can remember what we're doing, and we're going to want to find, in this particular case, p prime of x, the derivative of x. So let's go through this. We're going to work through cost, revenue, and then profit. So cost. The marginal cost is the derivative of cost, so c prime of x is equal to 2. And we want to know the cost at 2,000, the marginal cost at 2,000, so c prime of 2,000, that's easy, that's still 2. And dc, the approximate change in cost is going to be c prime of x times dx, which is 2 times dx. dx is 10 because we're changing from 2000 to 2010. So 2 times 10, so this is 20. So we estimate that costs increase by 20 as production increases from 2000 to 2010. So now we'll look at revenue. So revenue, we want to find the marginal revenue. So that's just the derivative of our revenue function. So that's going to be 10 minus 2x over 1,000, which is x over 500. We want to know the marginal revenue at a production level of 2,000. So that's 10 minus 2,000 over 500, which is going to be, that's 4, so 6. And so now the approximate change in revenue, which is the marginal revenue times dx, is going to be 6 times 10 equals 60. So finally, we're going to look at the profit equation, which of course we don't have up here, but we know that the profit equation is the revenue minus the cost, which means the derivative of the profit equation, the marginal profit, is the marginal revenue minus the marginal cost, which means that the marginal profit at 2,000, production of 2,000, is the marginal revenue at 2,000, which was 6, minus the marginal cost at 2,000, which was 2, so that's equal to 4. And now we can estimate the change in profit using our differentials, so that's p prime of x times dx, which is 4 times 10, which is 40. So we estimate that costs will increase by $20 if production has increased from 2000 to 2010. Revenues will increase by $60 if production has increased from 2000 to 2010. And profits will be increased by $40 if production is increased from 2000 to 2010 units per week.